So in this video here, we're going to take a look at how we can train a custom YOLOv9 model on an instance segmentation dataset. So the dataset that we're going to use is a crack segmentation dataset. So we just have a whole dataset with a bunch of cracks inside of it. And then we're going to train a custom YOLOv9 model to be able to determine the location and also create a mask of the cracks in our images. So let's now jump straight into the Ultralytics documentation. If we go up in the top, we can see we have the models tab, then we can go down and see YOLOv9. So if we hit YOLOv9 here, we can see that all the different details and so on. We both have training, inference, validation, and you can also export and so on. So you have all the different tasks with YOLOv9 as well. You can read about the details here. We already have videos covering how you can do object segmentation and all of that. For YOLOv9, we can both do instance segmentation and also object detection, where in this video, we're going to do crack instance segmentation. We have some different variations here. We have tiny, small, medium, and then we have our C and our E model for detection and also segmentation. So for segmentation, we only have these two models available for now. So this is the model that we're going to use. We're going to use this code snippet. We can copy paste it directly into Google Colab Notebook. We can also use the Ultralytics hub to train our models directly, or we can use our own local machine in a custom Python script. The only thing that you have to do is copy paste this code and specify the YAML file for your dataset. You can also do it directly with the YOLO command in your command line interface. So let's now going to take a look at the datasets. If you go inside the datasets tab up at the top, we can see we have all these datasets directly available with Ultralytics. So you can just specify the data, YAML file, and it's going to download the dataset automatically. You can also use your own custom datasets. We have tons of videos already covering that. How you can set up your dataset, annotate it, connect it to the Ultralytics hub, how you can use it to train a custom YOLOv8 model, and now also YOLOv9. So the dataset that we're going to use in this video is the crack segmentation dataset. So let's now just go inside that tab and zoom in a bit. So here we can see some details about this crack segmentation dataset. You can see the dataset structure. We have almost 4,000 images in our training set. We also have some images in our test set and validation set. So we have different applications. It could be cracks in walls, the floor, ceiling, and so on. We basically just want to segment out every single crack that we can find in the images. Then we have our dataset YAML file. We have the path, the training, validation, and test paths as well. We have the classes, so we just have a single class for this dataset, which is the crack, and then we're going to have a mask, basically predict every single pixel that is a crack in our image. This is the URL for downloading the dataset. All of that will be taken care of. We just need to call this YOLO command, train, specify the model that we want to use, and specify the data YAML file path. So that's pretty much it. We're now good to go. We can see this sample data and also annotations. So we have a bunch of different cracks. Could be in the wall, could be ceiling, floor, and whatever. So we just have all these cracks, have our annotated segmentation mask, and then we're just going to create a model, train a custom model, being able to detect and segment out these cracks in the images. So this is a pretty cool real world project that can be useful in a lot of different applications and projects. So right now, let's just jump straight into a Google Colab notebook. We only have to specify and run a few blocks of code and we have everything up and running. You can also do the exact same thing on your local machine or whatever environment that you're using. So first of all, if you're using a Google Colab notebook, you can change the runtime type and we can specify the GPU here on the free version. So you can use GPUs for free on Google Colab notebook. So here we're just going to click save. We can connect to the runtime. First of all, I'll just run this command, which is called NVIDIA SMI. Just shows us all the information about the GPU connected to our environment. So right now we can see we have the Tesla T4, and that was also the one that we chose inside the runtime settings. I have 15 gigabytes of RAM here for GPU. So now we're good to go. We can train our custom YOLOv9 model for instance segmentation on a GPU. Now we need to pip install Ultralytics exactly in the same way as you do locally. That's everything that we have to do. Just make sure that you install the latest version always. After we've done that, we can go down and just copy paste the code directly from the documentation. You don't have to write any code at all. It's only a few lines of code that you need to specify. And right here, you can just have this -seg when you want to run segmentation. If you delete this part, you're actually just running object detection. We can also run with the YOLOv8 model, small, medium, nano, whatever model that you want to use. This is how easy it is to use with Ultralytics. So there we go. We have our segmentation YOLOv9 model. We can get the model information, and on our model instance, we can call the train function here directly. We specify the data YAML file, so our crack dash segmentation, it's going to download automatically. So this is the file that I showed you inside the documentation. We specify the number of epochs. We're going to run 30 epochs in this example, image size, and also batch size. So all of these parameters, we have videos for all of them, explained them. You can also read about them in the Ultralytics documentation. You can see all the values, a short description of them, and also all the values and arguments that you can throw into this train function. So this is pretty cool. We're good to go. Now we can just run this block of code. I already did that because every single epoch is taking 4 minutes. So it's like 2 hours to train this whole custom model because we have 4,000 images. You can get away with a few hundred images if you have a data set. Do instant segmentation, object detection. You don't really need like thousands of images. You can get away with a couple of hundred images and then just fine tune a pre-trained model to solve that specific problem. Then you can export the model, use it in your own applications and projects, but we already have videos about all of that. So definitely check those out. So right now it's just training. We can go down and we get a summary of our model. If we just scroll up to the top. So right now we can see that it didn't find this dataset YAML file. So it goes in and automatically downloads it. So we can see it start to download. We get the summary of the model, so all the individual layers. And now it's just going to load in our training set and also validation set. We can see we have our almost 4,000 images, 200 images in the validation set, exact same values as we saw inside the documentation. So now we're going to take a look at the epochs that we are running. We have our losses. I'll just have to scroll a bit over to the left. Let me just zoom out so you guys can see what's going on. So if I just scroll over here, we can see the mean average position. It's a bit bad formatted right now. We can see the losses, they are over here. They're decreasing over time. We have our segmentation loss, class loss. Again, we only have a single class, the box loss. It is basically just a localization error. So we make sure that our model acts like segment out the correct pixels. So that is the segmentation loss and also the box loss. So how is it fitting a bounding box around our segmentation mask? We see the number of instances, mean average position, and also our precision and recall. So those values are over here. We can see we have our mean average positions in the last 2 columns here, and then we have our precision and recall. And all of these values should be increasing over time and ideally go towards 1 and converge. So we can see the mean average positions, they're increasing really nicely. So that's good to see. And we can see that it kind of like has already converged here at around 0.6, at least for the mean average position of 0.5. So if we take the confidence of the predictions at 0.5, how many correct predictions, what is the accuracy for all our classes, and that's basically our mean average position. We also have our precision and recalls here, which is also going up. Ideally, we want to have them larger. You can test out different variations of the model. This is the smallest YOLOv9 model, and it hasn't fully converged yet, or at least it's not done training. We still need to run it for at around 9 epochs. Then let's get back, take a look at the results and see how we can run inference with it and see how the model performs. So our model is now done training for 30 epochs. It took around 2 hours. We have the validation results down here at the bottom, 200 images. We can see the number of instances. We have the precision recall for our boxes and also our mask. So we can see for our bounding boxes, we have pretty good mean average position and also precision and recall, where it's a bit lower for the total mask because it has to segment out every single pixel. So the average position is a bit lower on that one. We can see that the validation, all the results are stored inside of our runs directory. So if you go over to the left, we can also see we have our data set. So the crack segmentation data set, where it basically downloaded and extracted our data set. We can see our runs folder, segment, train, and we have our weights, so we can both extract our best and also the last epoch weights. So if you just right click on it here, you can just hit download, load it into your own custom application and project in Python or whatever that you're using, and then you can just use that custom trained YOLOv9 model directly. We also have all the other different curves, graphs, confusion matrix, and so on. The confusion matrix doesn't really make too much sense when we're just dealing with a single class, but ideally we want all the values to be in the diagonal. We can see we have some false predictions here and there, and we also miss some, but again, we have most of our predictions here in the diagonal. So we can see we have our results. We also have a PNG file, which we can take a look at. So right now, these are just all the training graphs. We have our losses, segmentation losses. They're decreasing over time, haven't fully converged yet. So it could probably have been trained for longer, maybe 40 epochs, but that will take almost an hour longer. We have our precision, recall, kind of like starting to convert here, but we have pretty nice values. And we can also see mean average positions. They're still going up, but we have some pretty good results already. So yeah, that's pretty much it that we need to take a look at. It looks good. We can also go in and take a look at some validation batches. So this is just a batch from our validation set that we throw directly into the model, and then we get the predictions out. So these images, the model has never seen these before. It's just detecting all the cracks that it's able to extract from the images and segment them out. And we see that these are actually like some pretty good results. We get really high accuracy. Even on this one up here, I can barely see the segmentation mask or like the crack myself, even if I zoom in. So we can just see we have this very tiny gap and all like crack in our image here in the wall or ceiling, and it's able to extract it with the YOLOv9 model on this custom dataset that we have trained it on. So right now we have our model. We can then go in and use it. So let's just close all of these, and we should be able to run inference as well. So we can just go in and copy paste this code directly. Again, now we're just going to create an instance with our best weights, just to make sure that we're actually using that. But we already have the model that we can run inference all already, but let's just make sure that we actually use the correct one. And I just want to show you guys how you can use it in your own custom application. So right now we just create a new instance of our model. We can display the information again. We don't want to do that. Now we don't want to hit train, but now we want to act like process as single image. So right now let's just go inside our data set. Let's go inside our test set images, and let's just take an arbitrary one. I'm going to copy the path, and then we can throw it directly into our model. We can either just throw it directly into the model or call the predict function as well. And then it's going to return the results inside the results variable that is going to return. You can extract all the results, the bounding boxes, segmentation mask, confidence scores, and so on. But we have videos covering all of that, so definitely check that one out. Now just run this block of code. It's going to load in the custom trained YOLOv9 model and do inference. So we can see it was pretty instant, around 70 milliseconds to do inference, and it's going to save the results as well. And we can see that we're detecting a single crack in our image. So this is how you can train a custom YOLOv9 model and also use it in your own custom applications and projects. So definitely go in, test it out, try to do it on your own dataset, or you can use the ones from Ultralytics that is available directly. So thanks a lot for watching this video again. I hope to see you guys in one of the upcoming ones. Until then, happy training.